Hey everyone, I think we're going to get started here. The title of my talk is Web-First Data Visualization in Python. I'm going to be covering a project called Lightning that I helped develop. My name is Matthew Conlen. A little bit about me. I work at 538. I'm a computational journalist there, which means I do a lot of data visualization for their stories. And I also work with Jeremy Freeman in the Freeman Lab at HHMI Genelia, which is where this project comes from. If anyone was around yesterday to see the binder talk, this is the same lab. So first question I want to address with Lightning is, like, do we really need yet another way to plot data on the screen? And probably not. This this isn't trying to be like an end-all be-all charting library. It's not trying to replace ggplot or anything like that. Really, the goal of Lightning is to connect your data, where you're doing the analysis and where you already have the data, to visualizations that people have already made. So especially on the web, using JavaScript and D3, we want to be the bridge between those two things. So yeah, you want to keep your analysis code where you're comfortable with it in Python or in R, if you're one of those people, and then use kind of the best tools for the job when you're actually doing the data visualization side of things. And so from my perspective, that is JavaScript and D3, and we want to use all the modern libraries that are available. This was kind of built out of a frustration of my own that you could go to blocks or all these really cool examples of interactive visualizations online. You could see the code, you could see how they run, but there's no way to like put your own data into these. Like, they're just stuck on the web as they're interactive, but they're also static. So Lightning provides a way to pipe your data into these things really easily. And the way that it does that is by exposing an API. So this is kind of like the tagline for the project. It provides an API-based access to reproducible web visualizations. And the way that that really works is that there's a REST API. You send JSON to it. You say, I have this data. I'm going to provide you with it in the post request, and I want it to be displayed with this type of chart. So you can say, like, I want a line graph, or I want a scatter plot, or whatever. And it will generate a web page, a URL, an image, whatever way you exactly want it to be displayed. That's how it will return. So here's an example. Like, this is all you're sending in the post request, and then you get back like this page with your visualization on it. This one in particular is rendered with 3JS, so it's a 3D scatter plot. But it's kind of whatever type of visualization you want it to be. So we provide a few defaults, but you can plug in any JavaScript visualization to the system. And I'll show you exactly how to do that later on. So client-server model is kind of the basis for this whole thing. We have this nice abstraction between our analysis code and the code that's doing the rendering of this stuff. And it gives like a few benefits right off the bat that you wouldn't necessarily expect. Like, one, we automatically get like updating and streaming on our visualizations since they're persistent and they have this service backing them. They're reproducible, so if you have data and you create it, you can just do the same exact thing with new data, and you'll be able to see different changes over time. Like, you're not messing with HTML files or just like putting your data into some JSON blob or something like that. It's all in your workflow and like very solid. It's shareable. You get a link, you can send it to your friends and show it off. And you can also get state. So like, if the user is interacting with the visualization, you can query that and say, like, what is the current state of this visualization? What has the user done to interact with it? And you can sort of do further analysis based on that. So this is just a quick what the website looks like. If you go here, these are kind of all the visualizations that we have by default. I think there's like maybe 15 or so by now. If you click into any one of them, you get this like live editor that shows you, okay, this is what our line visualization looks like. You can play around with it. It's all interactive. And then you can actually change the data and stuff down here to see exactly how it will respond to you. So if you ever want to just get like a quick overview of what this can do, just go to the website lightningviz.org and you can play around with this editor. So here's another example, a little weirder one. This is a 3D volume rendering of a color cube. And you can see this one's rendered with 3JS again. And if you like scroll down here, there's always example code that shows exactly how this thing was created. So here's the Python on the site that was used to create this visualization. So to set this up, there's a few ways to go about it. Because it is a client-server model, you need the server. This is written in Node. You can install it with npm. We give you an executable. It's like a one-line install. You can install it via a binary that we distribute for OS X. Or we actually have a public server running. So this link, public.lightningviz.org, if you don't want to go through the trouble of like setting up your own local server, you can just start using that, and it will work out of the box for you. For Python, we actually provide the ability to do all this without a server at all. But you lose some of the benefits. And I'll talk a little bit more about like the pros and cons of doing that. It's good for like high performance type situations and situations where you don't want to be bothered to install the server for quick testing or something like that. But I recommend usually going with the server. If you download the app, this is the screen you get. It's a typical OS X. You just drag it into applications and launch it, and you'll have a server running on your computer. Once it's running, this is what it looks like. You get a welcome screen with a sidebar. Things are kind of bucketed into sessions so that you can keep track of visualizations that you've made. But the cool thing is you can see this page, all the visualizations that are in here. So each one of these is something that you can send data to and have it display with your data. And then you can click through and see exactly what that looks like. And you can even, like, since these are all JavaScript modules, you can use this page to import new ones or custom ones that you make. And at the end, I'll go through an example of doing that. This is a Python setup. It's pretty easy. Hopefully everyone is familiar with this. If you don't like pip, you can clone it from, it's on GitHub. Searching Lightning Viz Python will give you that link. So here's a first kind of simplest Python example. Let's see if I can get the screen. Okay, so the first two lines are just importing the libraries. The second one, where we instantiate the client, LGN equals Lightning, we pass in the host. So I don't have a server running locally for this example, but I pass in this public URL. So that tells it, use that as my backing server. Then I create some random data using NumPy's random function, and I plot a line plot. So that line v equals lgn.line is what's actually plotting it. We get a reference to the plot, and then we can call open, and it'll open it in your browser like this. And since we're using the public server, like you have a link that you can send to people now. These are all, on the public server, they're all anonymized in the same way that GitHub gists work, like secret gists. So no one can find your visualizations, but if you share the link, then people will be able to access them. So in this line here, next to 6, lgn.line, the LGN object has a function for every single different plot type, basically. So there's a .line, .scatter, .histogram, all this stuff. And this is kind of the list of everything that's in there by default. You can go through, I'm not going to go through everything right now. This is all in the documentation. But it's just exposed as a function on the top level object that you can call. You just pass in your data and whatever options you want to provide. So another cool thing that you can do is, same as the last example, but now I'm providing a description field. So this is a pure markdown description that I can add in when I'm plotting. And since I already showed you that you get like a web URL for this. It will render this markdown next to your visualization. So if you want to annotate anything or provide detailed descriptions of the analysis that you did to get there or anything like that, you can use this tool to create like a nice standalone web page that can represent all the work that you put into this. It also works in notebooks, in Jupyter and IPython. To do this, you just have to pass in an IPython flag, set it to true, and then by default, everything will just start showing up in line here. And of course, it's all interactive in D3 and stuff. So these are just kind of our sample scatter plots and the different options that you can pass in. But everything works just out of the box in IPython like this. And here's a link if you want to see these example notebooks. There's a whole collection of them. They go through pretty much every single different plot type that we have and go into detail on all the different options and things that you can pass in. I'd recommend checking this out as like a good first starting point if you're not familiar with the library yet. Yeah, by the way, if anyone has any questions at any point, just feel free to stop me. Yeah?
So you had like the API had like 10 types of plots.
Uh-huh.
But the plots, the types of visualizations you showed somewhere in Lightning had like many more. So.
Okay, so like for example in.
Like in the actual Lightning app on the left-hand side.
Oh, yeah. So I think one of the things that is different there is that there's also plot types that are images too. So there's like maybe 4 there that aren't shown up. But in general, it's a one-to-one mapping of everything that's in there will be on the top level. It's possible that something just got cut off of the screenshot too. But yeah.
You might be getting here, but if not, how can you customize the built-in ones? Like, do you have to write your own JavaScript, or is it also part of the API?
So certain parts of it are part of the API, like different colors and sizes and axes, labels and stuff like that are passed in as configuration options. And then if you want to do like much more in-depth customization than that, you can drop into the JavaScript and do it that way. And I'm going to go through an example of doing exactly that at the end. Cool. Everyone else on board? All right. Annotations, we've got our notebooks. Let's see. Okay, so in addition to just being able to create these things, I mentioned that we can actually get information back about like what the user is doing here. So actually every single visualization that you create stores just an arbitrary dictionary of key value pairs that are defined per visualization. So scatter plot could have like selected points, for example. And then you're able to query that at any given point and see what the user has done and sort of take further action based on that. So this is a more concrete example. This is using one of the image rendering functions. So I'm taking the example images from scikit-learn and using it to just display images with this type called Lightning Image Poly. And what Image Poly allows you to do is draw polygons over top of the image. So if you want to annotate or select certain regions of the image, you can go in and select it here. The selections are stored in this dictionary. So if at any given point, if the user has made selections, you can get that information back and then sort of run subsequent analysis or do whatever you want with that information. So, I mean, in this example, I'm just like creating a new plot with those predefined, but you can imagine doing, I don't know, any sorts of things with this, like running more in-depth regressions on just like one part of your data or whatever. So that's what this is good for. It's also possible to define callbacks. This is only possible in the Jupyter Notebook environment, but in a similar way, you can listen for events and say, like, on this event, run this Python function. And I don't have an example of this, but it's basically the same idea as what's going on here, except you don't have to query. So you can also update the data in the plots and append data to it. So every plot that you create has an update and an append method. Update just completely replaces the data that's inside of there. Append adds it to the end of the array in a way that makes sense. And some of them are particularly well suited for these types of operations. So we have some streaming types of visualizations. So like we have a normal line plot, but we also have a streaming line plot. We have a normal scatter plot, but we also have a streaming scatter plot, which all of the differences is that it makes the append method much nicer. So if you're using append on this streaming line plot, this is what it'll look like. So you can use this to build kind of cool dashboards and things like that, and see how it's changing over time. This is the complete code to generate that. It's very similar to the first example I showed, except we're just appending. We're using the line streaming function, and then we're appending at the end. Similarly, with the scatter plot, we can have streaming scatter plot to where points fade out over time and come in over time, and you can define different behaviors based on that. And it's the same idea here. You just do a streaming scatter plot, and you're appending data to it all the time. So you can run this in Python without a server. There are a few advantages. One, it's faster. You don't have to do a round trip to the server and back. You're just piping straight out of Python. And the way that we do this is basically by bundling up all of the JavaScript that the server would normally provide, minifying it and packaging it with the Python client. The sort of disadvantages of this are that that JavaScript is then stuck there. Like you can't add new custom visualization types to it. You only get the default ones, and you don't get this cool persistence, and you don't get the ability to query for the states. So it's a fully featured D3 interactive plot, but it doesn't have all the stuff behind it really. So just going to talk now quickly on what exactly goes into making a custom visualization. So everything in here is a module. If anyone's familiar with JavaScript and NPM, everything is a module on NPM in the same way that it would be a package on PyPy, for example. So every single visualization that we have lives in a separate GitHub repo. They're all super easy to find, and the code is nicely separated. So if you want to make any changes, you can go to GitHub and check out the code and see exactly how everything works. There's no magic to it. There are a few advantages of doing it this way. One is that this allows the server to build the packages on demand, which means that we can require any JavaScript library that's on NPM. So if you want to have a new visualization that uses some crazy new library that came out last week, you can do that without updating the server at all. It just plugs in. You can start using it. And to start making your own or customizing these things, we provide a Yemen generator, which will just skeleton out a little project for what a custom visualization looks like. It's really just one JavaScript file that looks like this. So you're extending the base Lightning visualization, and you basically have to fill in a few functions here. It's like an init function and a render function, and then a function to transform data if you need it to be transformed in any way. So for example, this is just a JavaScript charting library called chart.js. If you wanted to plug this in to Lightning and start creating plots from your Python code, what you would do is you would have this structure, and then you'd go in, let's see, essentially you would fill in the init function, which is it needs a canvas on the screen, so I draw a canvas, and you fill in the render function. It needs to be initialized with this chart library JavaScript, and then you can just go to this screen on your server and type in the module name. I just called it I think, Lightning custom example for this one, just because it was a test. But what this is going to do when I hit submit is it goes on to NPM, it pulls down the package, it compiles it, and brings it into your Lightning server environment. And then you're going to be able to start using it and interacting with it in the same way that you can interact with it with all the default visualizations. So like that live editor that you saw before and like the Python APIs will exist. So it takes a few, like 10 or 20 seconds to actually come in, but now you have this visualization that Lightning is rendering. You can actually go in and it's all live. You can change the data, and you can call this from Python. It's like just completely in the ecosystem now, and it's really easy to like get it in there, which is the idea of this whole thing. Let's see. Anyhow, that is what I have for you. I went over pretty quickly all of the kind of high-level functionality. So if anyone has particular questions, I'd be happy to answer them. Yeah.
How easy is it to like tweak them slightly, like with the line chart, as time was moving, you saw the axis move, so like let's say fix the axis, maybe add some like axis titles and etc.
So there's kind of two answers. Is like one, if it's already exposed through like the options parameters, you can just pass that in through Python. If it's something that doesn't work, the process would be like you clone the version of it that's on GitHub locally. You make your changes there, and then you, in that same like panel that I showed to bring it in, you would just bring in your local version, and it, like, depending on how long the changes take, I mean, you could do it in like 5 minutes or something. Yeah. Cool. Anyone else? Yeah.
Have you guys thought about ways to increase 15 to a much higher number by involving the broader community? Like, if everyone's just making custom visualizations, how do they get them to be shared with everyone?
Yeah, I mean, that would be great. I would love if people did that. A few ways that we do that now, or try to help people do that, is just through, one, the project, like the skeleton generator. It includes a few keywords. So like if you publish any custom visualization that you made using that generator, it's tagged under like a Lightning Viz keyword. So those are all searchable and indexed on NPM. So you can see all the ones that people have made that way. Yeah, the other thing is just getting more buy-in from like JavaScript people, I think. The project has been pretty popular on the Python side of things, but not a ton of JavaScript love right now. So, but yeah, if people want to make them, and we're happy to share and like make them available for anyone who contributes one. Cool. Thank you for listening.